Hey, what's up, guys? We're going to be starting chapter 2, which is over reasoning and proofs. Uh, you could also call this like a logic section. So in this chapter, there's not really going to be arithmetic or anything of that nature. We're just going to be observing certain types of statements uh, and doing a bunch of logical conclusions with those statements. So let us begin. So 2.1/2.2 is over inductive reasoning. So in chapter 2, we'll learn about two different types of reasoning, how to tell the difference between them. But to understand them, we need to be familiar with a pretty simple concept first. So conjecture. A conjecture is an unproven statement that is based on observation. It's an educated guess. And really, we do this every day. Like if you notice someone wearing a football jersey, you might assume that they are an athlete or at least a sports fan. That is a conjecture. So you make conjectures every day when you wake up in the morning, deciding on what to do first, get dressed, eat breakfast, brush your teeth, is all determining a conjecture. For example, it's cold outside, therefore you will wear a sweater. You can also look at it's raining outside, therefore you will bring an umbrella. Most of us are probably bad about that. Then we see here truth value, and then it has arrows pointing to T and F for true and false. So a conjecture must have a truth value. You must be able to derive a truth value from it. So a conjecture can be true or false, but it does need to be a statement in which you can derive a truth value from it. So for example, something that's not a conjecture is me saying something like, blue is the best color ever. Well, that's not a conjecture because there's no way to really get a truth value from that because that's subjective. That's an opinion. Okay. So a conjecture, you must be able to derive a truth value. Now, counterexample. So when a conjecture is false, we can typically debunk it or disprove it by just simply stating a counterexample. So a counterexample is, I don't like the word the there, but it is one example it takes to show a conjecture is not true. So the reason why I kind of don't like the word the in front of there is there can be more than one counterexample. In fact, there could be an infinite number of counterexamples, but you only need to state one of them to disprove a conjecture. For example, if I said something like all numbers are even, well, clearly that's false. For a counterexample, you could just say the number 3. 3 is a number, but it is not even. It's an odd number. And obviously, there's an infinite amount of odd numbers. So you could say 3, 5, 7, 9, so on and so forth. But you only need to write one. That's all it takes to debunk a conjecture. Because in math, we like to speak in a very general sense. So when we say a conjecture, we're trying to say it's true all the time. So if it's not true all the time, again, one counterexample is sufficient. Let's look at some examples. So all birds can fly. Is this true or false? This is false. And a counterexample I know would be a penguin. Penguin is a bird, but it can't fly. I'm sure there's other birds you could name. My bird knowledge is pretty limited. I know penguin for a fact, though, would work. Next, it says if it is a fraction, then it is a number between 0 and 1. So this is also false. Okay, something like 3 over 2 would work. That's a fraction. As a decimal, it's 1.5, and that's greater than 1. and greater than 0. So it's not between 0 and 1. You could go 5 over 2, so on and so forth. There's an infinite number of counterexamples. And you could also give an answer. I kind of like to call it the smart aleck answer. You could even say something like 4 over 2. So clearly 4 divided by 2 simplifies to 2, but you can still express it as a fraction. Because note that the conjecture didn't state that it had to be a fully simplified fraction. It just said a fraction. Let's go on to some of the others. So conjecture 3, if a number is divisible by 6, then it is divisible by 3. This is true. We might be able to prove this later, but again, same thing, like if you're divisible by 4, then you are divisible by 2. Conjecture 4 states if an angle is obtuse, then it is 125 degrees. So again, this is false. So to speak more on that, so yes, 125 degrees is an obtuse angle. But the conjecture stating if an angle is obtuse, then it must be 125 degrees and only 125 degrees. That's clearly false because an obtuse angle is an angle greater than 90 degrees. So 91 degrees would work, 126 degrees would work, 124 degrees would work, so on and so forth. Again, you only need to put 1. But considering we can have decimals as well, there's an infinite number of counterexamples to that. 5 might be slightly tricky. It says if 2 angles are supplementary, then they are not congruent. So supplementary, again, means 2 angles that add to be 180 degrees. And it's saying that if 2 angles are supplementary, then they are not congruent, meaning they cannot be the same angle. This is false. And there's actually only one counterexample on this one, and that is if both angles are 90 degrees. These are supplementary angles that are congruent. And that is it for this part. Thank you.